Hey guys, today we are going to be graphing trig functions. So we talked all about the different trig functions and exact values, etc. And now we're going to take that knowledge and put it on a graph. So our essential question today is, how do I determine the amplitude and period of a sine or cosine function? So just looking at that essential question, we've got some vocabulary to go through today. And we're first going to start by learning two new parent functions, one of which is y equals sine of x. So this is going to be our function that we kind of saw with those spaghetti trig, so the sine graph. We are going to plot this one in degrees first, just to kind of get ready for doing the radians. But what we need to think about are some critical points, or some special values that are going to make graphing this equation easier. So if you remember those special quadrant border angles, or the OIO thing, those are going to be the most important things that you learn this year. Because when you look at it, this is going to make graphing my functions a lot easier if you know those critical values. So I'm going to start with that 0-degree angle, 90, 180, 270, 360, etc., etc. Okay, so those are those special quadrant border angles. The sine of 0 degrees is 0, because that's the y-coordinate there. At 90, it would be positive 1. At 180, it would be 0 again. Again, that's the y-coordinate. 270, it'd be negative 1, because we're down here on this axis. And then at 360, it starts repeating, so we'd have 0. And we could keep going. If you went ahead and you added another 90 in there and you got 450, you would have a 1. And we could go backwards too. We could have negative 90, and that would be going backwards, and so I would get a negative 1. Okay, so let's take those points and plot them. The first thing I'm going to do is mark my x-axis with those x values that I just found. So I have negative 90, I have 0, I have 90, I have 180, I have 270, 360, and 450. Okay, so those are my x values. I look at my y's and I notice that my highest y value is 1 and my lowest y value is negative 1. And then I'm going to go ahead and plot those points. So at negative 90, we have negative 1. At 0, 0, 91, 180, 0, 270, negative 1, 360, 0, and 450, 1. Okay, now the one thing here, it might look like this is going to be a bunch of v's, but we kind of saw with our spaghetti trig that these are actually going to be nice curved graphs. So I'm going to try my best to curve this. Oh yeah, I'm already messing up. Well, we're trying. Well, it kind of looks curved, and I totally, here, whatever, that's one. Okay, you get the idea here. So, again, when I'm looking at this, I could have repeated it. I could have kept going. I could have put negative 180, went up again. I could have gone over and kept going around my circle, because right, I have a circle and it just keeps going. So, when I look at this, this is what the graph would look like. It's going to start here at 0, go up and down. This is actually called a sinusoidal function. It just kind of means a wave. And if I really quickly look at my calculator and I type in the sine of x, and I'm in degrees mode, and if I want to look at my window, if I just graph it right here, it's going to look kind of funky. If I go into my window and I change it into the values that I was looking at, so negative 90 to 450, I could change my x scale if I wanted to be 90, so that way it looks a little more like what I have. But I'm just going to go and make my y min negative 1 and my y max 1, and I hit graph. So you notice that's exactly what we graphed. So if I wanted to go into my window and make it a little bit bigger and keep going until like 1080, which we know is a couple rotations of a circle, you're going to see that we just keep waving around, and it just keeps repeating after those critical points. So that kind of leads us into the next piece, where we talk about the cycle and period of a function, of a sinusoidal function. So the first definition we need to know about is called the cycle. Okay, a cycle is the section of the graph before it starts repeating, of a sinusoidal, of a wavy graph. So if I look right here, if I start right here at the 0 point, I've gone up and down, and then I'm back at that starting value. So my cycle has started here. That's important because a lot of times your graphs are going to ask you to graph 1 cycle or 2 cycles or however many cycles. Now, the reason we really need to know a cycle is because of the word period. And I'm going to go ahead and move my equation away. It's in the way. Okay, and so a period is the number of degrees in a cycle. So the number of degrees, or perhaps radians, if we go into radians, that complete a cycle. So if I look at my graph of sine of x, I look and if I start here at 0, it took me the entire 360 before it started repeating again. So the period of sine of x is 360 degrees, or if we were in radians, that would be equivalent to 2 pi. So we've graphed sine of x here. This is our new parent function. If you know your critical values, where your quadrant border angles are, it's pretty straightforward to graph. So let's go ahead and see if we can figure out the cycle, period, etc. of cosine of x. Okay, so we're going to graph cosine of x kind of the same way that we did before, but I'm going to go ahead and make us do this in radians. Okay, and so when I look here, I'm just going to again make an XY chart for myself of those critical values. So we have 0. Remember, 90 degrees is equivalent to pi over 2. That's the angle up here. Pi would be that 180 degree angle. 3 pi over 2 would be the 270. And then finally, all the way back around, your circle would be 2 pi. Okay, now cosine, remember cosine is your x coordinate. So if you're over here at 0 degrees on your unit circle, or 0 radians, you would have a cosine value of 1. Okay, up here at pi over 2, it turns into 0. Negative pi, it'd be negative 1. 3 pi over 2 is 0, and 2 pi is again 1. And again, it repeats itself. So when I go ahead and I graph this, my highest y value is 1, my lowest y value is negative 1. I have 0. One of my critical points is pi over 2, then pi, 3 pi over 2, and 2 pi. Okay, so I'm going to go ahead and graph those. So I have 0 goes with 1, pi over 2 is 0, pi is negative 1, 3 pi over 2 is 0, and 2 pi is 1 again. Okay, and again, we have that sinusoidal action going on. So this is going to be connected with a nice curve, maybe. I tried really hard to do that. And it's going to just continue to follow that same pattern. So one thing that you notice, sine started here at 0, 0. Cosine starts high, and it starts up here at 1. And then it goes down and starts to kind of make the same shape, but it starts at a different place. Okay, so what we need to know here is I have this beautiful graph, and the other pieces of vocabulary we need to know are first the sinusoidal axis. Okay, sinusoidal axis. Basically, when you are looking at a sinusoidal axis, it's just that horizontal line that goes through all the middle points. So if I'm thinking about where this graph, where the middle points are, not the high or the low, this one happens to be the x-axis. It's not always going to be the x-axis. Once we start talking about vertical shifts and maybe horizontal shifts, it'll move up and down, but for right now, my sinusoidal axis goes through those middle points. The other thing we need to know relating to the sinusoidal axis is the amplitude. Okay, the amplitude is basically the distance from the sinusoidal axis to one of those high points or to one of those low points. So it's the distance from that middle line, sinusoidal axis, to the top or the bottom. Okay, so when I look at this guy, I take any point on my middle, or up from my top, and I try to draw that line to that middle point. So when I look here, that's my amplitude. So for this case, the amplitude goes from 0 to 1 or 0 to negative 1, so my amplitude is just 1 of this graph. You notice the period is actually the same. It goes from 0 to 2 pi, so that would be 360. And my amplitude of this graph is also 1, just like it was of the other graph. Okay? If I was to ask you, though, about the domain and range of this guy, if I wanted to find the domain, you think about what kind of x's can you put in. Well, I could keep putting in radians or degrees forever in here. So my domain is going to be negative infinity to infinity. The range is what changes with these guys with that amplitude change. So the range is going to go from that low point of -1, and you can include it, and it's going to go up to +1. So again, domain can go forever, but that range is kind of stuck in between those two values. So that's the parent functions. Let's kind of talk about some of those phase changes.